Hello everyone, I am Arup Gorai, a MSc secondary student from IIT Patna. Today we are going to discuss complex number. So you already know about the natural number, integer, rational number, irrational number, real number, and here we will discuss the set of complex number which is denoted as C. And this is the set of complex number. You already know about the quadratic equation which is x square plus bx plus c is equal to 0. And you know the discriminant d is equal to b square minus 4ac. If your d is greater than 0, then you got two real and distinct root. If your d is equal to 0, then you got real and equal root. And if your d is less than 0, then what you get? You get the imaginary roots. So, Indian mathematician Malvira, when he tried to find the roots of this type of equation, x square plus 1 is equal to 0, and you try to write this equation in the form of x square plus bx plus c. So, what you will get? X square plus 0 into x plus 1 is equal to 0. Okay? So, what will be a d here? B square is 0 square minus 4ac. What is this? This is minus 4 and this is less than 0. So when your d is less than 0, then you will get the imaginary roots. Imaginary roots. Okay. So just try to find the roots of this equation. X square equal to minus 1 and x equal to root under minus 1. And this form you are seeing firstly. So this root under minus 1 is I will denote this is iota. This iota is a Greek letter and we will call this iota. Okay. So if you have any number which is the form of root under minus a like this type, you can write the form of iota. So let's see if you have root under minus 2. So you can write this root under minus 2 into 1. You can write this root under 2 into root under minus 1. And I already told you that this number is called iota and this is the unit of complex number. Unit of complex number. So you can easily convert the form of iota. So this is root under and this is root under minus 1 is called iota. So root of minus 2, you can write it root under 2 into iota. Okay. In this form, you can write root under minus 3 is equal to root 3 into iota. Now, like this type. Now, I will see the representation of complex number. So, we will represent the complex number as a z is equal to x plus iota into y. And this is called complex number. This is complex and this is the real part of complex number z and this is imaginary part. Okay. Now I will see when two complex numbers are equal. Let's say if you have two complex numbers z1 is equal to x1 plus iota into y1 and z2 is equal to x2 plus iota into y2. So here real part of z1 is equal to x1 and imaginary part of z1 is equal to y1 and real part of z2 is equal to x2 and imaginary part of z2 is equal to y2. So when real part of z1 is equal to real part of z2, that means x1 equal to x2 and imaginary part of z1 and imaginary part of z2, that means y1 equal to y2 are equal, both are equal, then you can say that your two complex numbers z1 and z2 are equal. Okay. Now I will see what is the conjugate of complex number. If you have a complex number z is equal to x plus iy, then you just change the sign of imaginary part. So what will it be? It will be z bar. And this is called conjugate of complex number. X minus, just change the sign of imaginary part. X minus i. So this is the conjugate of complex number z. Okay. So you have seen that z is equal to x plus iy and z bar is equal to x minus iy. So this is the important term. You can find z into z bar is equal to x plus iy into y and x minus iy into y. And what will be this? If you multiply these two, you will get x square plus y square, which is nothing but mod of z square. So easily you can write z into z bar as a term of mod of z square. Okay, and I will see some properties of complex number. So properties number 1, if z is equal to z bar, if and only if z is real. You can easily prove this. If z is equal to minus z bar, then if and only if z is imaginary. And real part of z or real part of z bar is equal to z plus z bar by 2. You just try to prove what is the real part of z. Real part of z is x. Okay, and real part of z bar, real part of z bar is also x. And what is z? Z is equal to x plus I over y, and z bar is x minus I over y divided by 2. Cancel these two terms. 2x by 2, you get x. So real of z is equal to z plus z bar by 2. Properties 4, imaginary of z is equal to z minus z bar by 2 into I. You just put the value of z and z bar, you will easily find the imaginary part. What is the imaginary object? This is y. Now I will see the polar form of z. So why we need to transfer the polar form? If you have the Cartesian product x, y, you can directly change this as the polar form r in, theta. Okay. So let us see. You have this Cartesian x and this is y, x axis and this is y axis, and you have any point in this x, y. Draw from the origin, and this is the r and this is your angle theta. So what will be the cos theta? Cos theta is equal to this part is x by r, and sin theta is y by r. So you get x is equal to r cos theta and y is equal to r sin theta. And you can easily solve this x square plus y square is equal to r square into sin square theta plus cos square theta is equal to r square. So this r is called modulus of complex number. So this you can write this z square. So x square plus y square is equal to z square. And you can easily solve the what will be the tan theta from this x and y. You just divide 2, you will get tan theta is equal to y by x and theta is equal to tan inverse y by x. So if you have any complex number in the form of x and y, you can easily transfer the polar form r and theta. Okay, I will see the organ plane. So this is your x. We have a complex number z is equal to x plus iodine into y, and this is your real part of x, real part of z, and this is imaginary part of z. So this is a organ plane. Here actually we are interested to find the argument of z. It is called theta, and this argument is called principal argument. And small argument of z, small a argument of z is called general argument. And if you ever to find the capital argument of z is the principal argument z, then it is easily to solve find the small argument of z, which is general argument z. You just add 2 and 5 plus theta, where n belongs to any natural number. Okay, and this is the infinite set because n is infinite. Okay, so argument of z or theta, how can you write this here? If your theta in the origin, that means if your z is equal to 0, then argument of z is not defined. and we are interested to find the angle of this complex number which is representing the argument of z. If your point in this position, what is the position? It is x is greater than 0 and y is equal to 0. So if your x is greater than 0 and y is equal to 0, then theta will be 0. We are going to find the angle in this direction, anti-clockwise. So your theta will be 0. If your theta in this position is a complex number x comma y, so your x is greater than 0 and y is greater than 0, so your theta will be tan inverse y by x. And if your theta in this position, that means x is equal to 0 and y greater than 0, so you will get pi by 2. And if your theta in this position, which is this is the x is less than 0 and y greater than 0, then theta or argument of z will be tan inverse y by x plus pi. Okay, and if your theta in this point, so this is x is less than 0 and y equal to 0, then your theta will be pi. And if your theta in third quadrant, which is x is negative and y is negative, then theta will be your theta will be minus pi plus tan inverse y by x. And if your theta in this point, so you can easily see that if your theta was this point, this was the theta pi by 2, and this theta will be minus pi by 2. And if your theta is fourth quadrant, then if your complex number z is fourth quadrant, then your theta will be tan inverse y by x. Okay, so this is the open plane, and we try to find how to find the theta or argument of z. If you are able to find the principal argument of z, then you can easily find the general argument of z with the add to n point. Okay, now we will see the De Moivre's theorem. Your De Moivre's theorem, if you have a complex number z is equal to x plus iy and here cos theta plus iota sin theta to the power n, then it will be cos of n theta plus iota sin of n theta. N is any integer. Okay, so you just multiply the power of n with theta. So you know, if you have x square equal to 1, square root of unity, x square equal to 1, and if you have square root of unity, then you get two roots. One is 1 and minus 1. This is the square root of unity. And when I will say that if how you can find the cube root of unity, then you will get the imaginary roots. Okay. Yeah, when I will tell you that find the square root of unity, you get two real roots. And when I will say you just try to find the imaginary root of unity, you will get imaginary. Let's try to find that root. If you have x cube equal to 1, and you can write this any complex number in the form of cos of 0 plus iota sin of 0. So cos 0 is 1 and iota sin 0 is 0, so you will be 1. So you can write it x equal to 1 to the power cube, and this one you can write easily in the form of, in general form, cos of 2k pi plus iota sin of 2k pi to the power 1 by 2. And by De Moivre's theorem, you can write is cos of 2k pi by 3 plus iota sin of 2k pi by 3. And if your k is equal to 0, then what will be the x? X will be cos of 0 plus iota sin of 0. So it will be 1 plus 0 into iota. And if your k is equal to 1, so you will get x equal to cos of 2 pi by 3 plus iota sin of 2 pi by 3. And you will get this is minus half plus root under 3 by 2 into iota. Okay. And if your k is equal to 2, then you will get the x equal to cos of 4 pi by 3 plus iota into sin of 4 pi by 3. And you will get this minus 1 by 2 minus root 3 by 2 into iota. So this is the one roots, this is the another roots, and this is the third roots of this complex number. When we are trying to when we are going to find the cube root of unity. So let us put the graphical representation of this. If your one root is 1 plus I into y, so let us this point is 1 plus into I, and this point is this, and we thought this point is omega and this is omega square. So this point is omega and this point is omega square, and you just draw a line from this and this, and here this angle will make 2 pi by 3, this angle will make 2 pi by 3, and this angle will make 2 pi by 3. Okay, and this is a equilateral triangle, and length is root 3. Length is root 3. This length is root 3. So when we try to find the cube root of unity, you will get three conditions. This condition is omega plus omega square is equal to 0, and omega cube is equal to 1. So like this type of way we get the cube root of unity. So in the next video we will see further we will discuss some numericals or some problems. Thank you for watching this video.